In this demo, we're going to look at a few ways an attacker may use the DNS system to get information about the computers in an organization, and also to compromise a machine and get access to information. Let's first look at doing reconnaissance using DNS servers. One way this can be done is with the nslookup command. You see that I have a PowerShell command prompt window open here, and if you just type nslookup, that will put you into this utility. nslookup is used to troubleshoot DNS server settings. You can see here that the DNS server that I'll be using is this one. It's the default one that I've configured for my machine here. When a computer wants to resolve a name, the first thing it does is look into a special file called a host file. We'll talk more about that later, but essentially the host file can contain mappings between domain names and specific IP addresses. If it's not in the host file, then an operating system checks its DNS cache. If the mapping is in there, then it uses the IP address that it finds. If not, it goes out and does the name resolution with the DNS server that's configured. In this case, nslookup simply allows you to do those queries by passing the cache that might be on a local operating system. If we want to, here, we can simply type in the name that we want to resolve like google.com, and it will go out and resolve that. My DNS server here goes out and says, I don't know what IP address that is associated with. And then it issues the query to the resolver that it's pointing to, and you see here the IP address of www.google.com. One vulnerability that exists with DNS servers is the ability to find out all the domain information associated with a particular name. One way we can do that is using the list command. We specify the domain that we want using the -d flag, and then we can say ajptech.net. This will tell us all of the computers that are associated with the ajptech domain. If you do that, you see that we have a full list of all the machines. Now, this is just a test environment. I've just listed a few servers, etc. You can imagine in an organization that has hundreds of computers, this provides very nice information to know which IP addresses we should spend time attacking based on these records. This is referred to as a zone transfer, and we need to make sure that our DNS servers in our organization don't allow zone transfers to just anyone. They're useful because you don't want just a single server, and so you want to share those records with other secondary zones, but you need to restrict who is allowed to do those zone transfers. Let's take a look at that. Inside of Windows Server 2019, you see here I've launched the DNS manager on the server. If you haven't installed that role before, it's super simple to do, and you do so before configuring these different zones. Let's go ahead and look at some of the properties that you might want to set. The one that's of most interest to us right now is the Zone Transfers tab. This basically specifies who is allowed to gather all those records at once, and you can see here that we have to any server. We could come in and just say no zone transfers are allowed, but as I explained a minute ago, that's useful because if this is the primary zone for that domain name, then you want to have a secondary zone. You don't want a single point of failure here, and so you want to be able to allow zone transfers. You can only allow servers in the Name Servers tab, which is nice because usually you set those up specific to a domain, and that would be anything that's listed here, or you can restrict it to a specific IP address. Let's go ahead and apply those settings. Let's say that we're going to only allow the following servers, and I'll just put in a fake IP address here right now. It won't resolve right now, but that's okay, but it will restrict those zone transfers. Let's go ahead and switch back over to our PowerShell window, and let's try that same command. You can see now that it says it has refused transferring all that information from the zone. Perfect. Now, when people are doing reconnaissance, they won't be able to see everything that we have in that zone. However, the domain name server continues to work, so I can say server 1, and you can see that the name resolution continues to work. So make sure you secure your zone transfers. Today, restricting zone transfers is commonplace. In fact, it's the default of many operating systems, and it's the best practice everybody should have. If your DNS server isn't configured that way, you want to make sure that you take care of that. Now, let's move on to a couple of other concepts. There are many different DNS attacks such as distributor reflection, denial of service attacks, cache poisoning, TCP send floods, and others. Let me just briefly explain one of these to give you a flavor. A distributed reflection denial of service attack occurs when several DNS queries are sent to a DNS server that has an open resolver, and that DNS server responds to the spoofed address with a large payload. The key to the attack is that the attacker only has to send a small packet of information to the DNS server, and then the DNS server sends a large response, but that response doesn't go back to the attacker, It sends it to the target that the attacker listed, using a spoofed source IP address. In short, the attacker uses the DNS to create a denial of service attack against the third party. In this case, you need to make sure that you don't have any open resolvers. An open resolver is essentially a DNS server that's willing to resolve names for third parties. Usually, you protect this in a couple of different ways. Either restricting the DNS requests that come into your DNS server, that is, you don't allow outside requests, or simply not having any forwarding capabilities associated with your DNS server, and making sure that recursion is disabled on your DNS server. Let me show you that setting quickly here. If you come to your server, you'll see the properties of the server itself. We are in the zone from before. We're going to go over here to the Advanced tab. You want to make sure that this option is set so that you disable the recursion. That, of course, disables the forwarders as indicated there. I'll say OK there. Then I'll come over to the Forwarders tab here. You can see that I'm set up, but it's not using those anymore. The downside of this is we need to use a different DNS server in order to do our name resolution. The server now can only do name resolution for the domains that are on it, but that's okay, that's best practice. You definitely don't want to be susceptible to those amplification attacks that I just explained. Let's come back here to our PowerShell prompt. A minute ago I explained that when name resolution needs to occur on an operating system, it first checks the host file, and then it goes to cache, sees what's in cache, and uses that if there is something that's associated with that name. And then it goes and does the name resolution using the DNS system. Let's go ahead and take a look at that cache. But before we do so, we need to make sure that we have something in cache. I'll simply go ahead and try to ping google.com. You can see that I get a response. Now, to see what's in cache, you simply say ipconfig/display DNS. You can see that I have several different entries in there. I have some of those entries because I have a browser running on my system and it's already resolved some names. Let's go ahead and try to clear that out. To clear out your cache, you type ipconfig/flush DNS. Let's ping google.com, and then let's go ahead and see if we can see just those name resolutions. You can see here there is only one record now when we display the DNS cache. Each of these records also has a time to live, as you can see there, and so they're constantly refreshing as the system is being used. One mistake that some people come across when they're trying to resolve DNS issues is they forget to clear out the cache. They hit a site that's in cache, they make some changes, and they don't realize that it's actually pulling it out of cache instead of going on. I want to make sure you're aware of how cache works. Now, what if we could poison the cache or insert a record in there that wasn't legitimate, that came from another source? This is a little bit harder to architect, but if we could specify a different IP address for the name server, the DNS server, we could pull records from it. It would be saved in the cache or locally, and then subsequent resolutions would pull the IP address out of the cache. Indeed, that's one attack that individuals use when exploiting the DNS system. I want to show you one other concept before we wrap up this demo, and that has to do with the host file that I mentioned a few minutes ago. This is the host file I mentioned a few minutes ago, and you can see that it's located in Windows System 32 /drivers/etc/hosts. In this file, you can include specific mappings between a domain name and an IP address. Before there was this DNS system, this file was distributed to all the computers on the internet, and so there's just a huge file of these mappings so that you wouldn't have to remember the specific IP addresses. Thankfully, the DNS system came along, making our lives a lot easier and being allowed to update, but this is still in place. And as I mentioned, it gets checked before the OS resolver cache, before going out to the DNS system to resolve domain names. You can see an example of how you can use this, but before I put in an example, let me show you a legitimate site so that you can see how this works. Let's go to catbounce.com, just a random site. You can see that there's something out there. If we want to redirect individuals, instead of them going to this site, to a different site, we can go into the host file and add a mapping that we're interested in. You can see that we put the IP address first and then the domain name. So I know that the DuckDuckGo server is at the following address, and then I can simply put www.catbounce.com and I'll save that. Recent browsers have incorporated a DNS cache inside of the browser itself. They do this because it gives them a competitive advantage to go ahead and resolve those domain names ahead of time, the minute that they show up on a page and that you might potentially click on. Let's open an incognito window to bypass the cache. If we go to www.catbounce.com, you see that it forwards on duckduckgo.com. I hope you can see how dangerous this could be. This is considered host file manipulation. However, an attacker could simply keep that in place and use. An innocent individual wouldn't have any idea that you weren't on the legitimate site. Consider banking sites or corporate sites. Anywhere where sensitive information might be shared. An attacker can get access to this host file, present what looks to be a legitimate website, and then siphon off data as you use it. It's also good to know that you can use host file to block malicious information if you're a systems administrator. This is a common site. It looks a little dated, but the information is pretty good on it. You can come and download a specific host file to block out a bunch of bad or malicious sites. The IP address you see is a null IP address. In other words, if we added this to our host file and you went there, it simply wouldn't go anywhere. One thing to note, you'll need to have administrator rights to adjust the host file. That's it for this demo. In this demo, we've looked at a few ways that an attacker can use the DNS system to get out information about computers in the organization and to compromise a machine and eventually grab sensitive information. We've looked at the NSLOOKUP command, we've looked at zone transfers, we've looked at securing the open resolvers, and we've looked at the host file and clearing cache. It's really important that you protect your DNS servers and make sure that you aren't taken advantage of in that way.